Hello again, everyone. This is a video lecture for Chapter 6. This one's going to be a bit shorter than the others because this chapter includes just a lot of definitions that, I don't want to just read every single definition to you. So I'll give you the big overarching concepts. The first of which is capillary action. In a nutshell, if there's a puddle of the water and you touch it, the water will cling to your finger. Well, that's capillary action. That's the ability of water to pull itself upward against gravity. And this is very important to plants, as you could imagine. So, when looking at the earth and water, it's good to remember that the vast majority of our water is in the oceans. Percentage-wise, very little of our water is fresh water, and of fresh water, most of that is frozen in glaciers. So of drinkable water, it's a pretty small percentage. The hydrologic cycle. Hydro, right, water, so that's the cycle of water through our, on the earth. In a nutshell, you have evaporation happening. Remember, that's the energy being put into the atmosphere, and that energy can then be released in precipitation, which then runs back and is re-evaporated. So you have a cycle there. Oh, I should mention, as you see, we got fresh water below the ground there. That's another part of the cycle. So I mentioned this before, but again, think of the air like a sponge. The air can absorb moisture, right? It becomes humidity. So when that sponge of air is completely saturated, right? You can't get any more water in it. In the air, that's a state of saturation. It's reached its maximum capacity, right? No more water can get in there. So let's say that you have your air sponge and it's saturated, and then it cools off. This could be because it rises in the air, or it moves into a colder area of the earth, all kinds of reasons. So that's, again, that sponge gets squeezed, and so it has to precipitate, right? Liquid has to come out, and that point is the dew point. You've woken up early in the morning, there's been dew on the grass. Well, that's because that air was cooled off after night, and so it precipitated out a little bit of water. So again, that doesn't have to mean rain, right? That moisture can be squeezed out in a number of different ways. Actually, a huge range of ways that you'll read about. So humidity. The main thing I want you to get out of this is that you have daily cycles of humidity, right? And you could look at the times a day and think about why this is. It gets warmer, it gets colder, it gets warmer, it gets colder. Warmer air can hold more moisture, and it thus, in general, is more humid, right? Not always, but in general. So vegetation, as we mentioned, that capillary action is very important for vegetation. That capillary action takes up water through the ground, and then it also gives it off through its leaves, and sometimes through its bark, or whatever kind of tree it is, or vegetation it is, I guess I should say. That's a lot of water that plants give off. So outside of just evaporation off of lakes and oceans and whatnot, plants are giving off that water, and so that's part of the cycle, right? The hydrologic cycle. All right. So evapotranspiration, that is the water either transpiring through plants or evaporating off of wherever water is. That's the way that water gets back into the atmosphere, right? So this map is an interesting one because it's showing potential evapotranspiration. Now it's potential because if you look at Florida and look at Arizona, they look similar here, but if you're on the ground in those states, you know they're not similar because, well, this is potential, right? So these places are quite sunny and have the kind of same elevation overall, right? And a number of other factors. But what they do not have the same of is, well, the amount of water available for precipitation. So that's the difference. So that's why this is potential here. You could read about this thorn rate system in a nutshell. You know, there are plenty of places, and that's why California is used as an example here, where you're going to have a water deficit. And so you have to go get some water, either purify some ocean water or go through an aquifer, right? You got to find some other way. So, how do raindrops happen? Well, you need a condensation nuclei, right? Condensation. So you need a little tiny particle of something that water grabs onto and collects to until it gets big enough to become a raindrop. Excuse me. And so before it's big enough to become a raindrop, it could be much smaller, such as in a typical cloud. And so things like fog, that's that process. And there's a good example here, actually. The foggy seas, sea salt is in the air, right? You can, if you're ever out by the ocean, you can kind of smell that salt in the air. Well, water grabs onto that. That's a great condensation nuclei, and so that's why you'll have fog more often in those areas. So speaking of fog, well, in a nutshell, so again, the atmosphere is like a sponge, and that's water in it. When it gets cooled off, that water has to precipitate out, and fog is one way. So, in a nutshell, you have some warm air moving over a colder area, for example. Well, that's squeezing that sponge, right? So that water is forced out. A bunch of different types of fog for you to read about. Read about all the definitions of clouds. I'm more interested in general, cirro, alto, strato, rather than knowing every single type of cloud in the world. But, read up on these. This is more stuff that you can read. Definitions, all the different types of rain and snow. There's tons of these. Oh, and these are some photos that were popular online a few years back of basically an ice storm, right? I mean, it's quite fascinating to look at what Mother Nature can do sometimes. Again, you could read about this. This is relatively self-explanatory. All right, that's it. On to the next lecture.